So to summarize what we've seen, n of t approaches 1. And p of t, product of n1 of t, n2 of t, n3 of t, goes to a constant c, which is equal to p of 0 divided by n of 0 cubed. So what does this mean geometrically? To see what's happening geometrically, let's look in the density space, or the number space. So let's plot now n1, n2, and n3. And first of all, capital N, which is the sum of the little ni's, adds up to 1. So that defines the plane in the n1, n2, n3 space, which is bounded by each of n1, n2, n3 equals 1 on the coordinate axes. And so it defines a composition triangle that looks like this. This is the region of space that has n1 plus n2 plus n3 equals 1. And the product n1, n2, n3, this is a hyperboloid of revolution that is going out in the first positive octant of the three-dimensional space. And the intersection of this hyperboloid with this plane n1 plus n2 plus n3 equals 1 is just a circle. So this is the intersection of n1, n2, n3 equals c. And then if we look at typical orbits, we've seen that as a function of time, capital N goes to 1. So if I start anywhere in the state space, I will be attracted to this plane. And then furthermore, I'm attracted to this circle. So some arbitrary position will be attracted to the plane and ultimately get attracted to the circle. Or some other spot below the triangle will go up and eventually be attracted to the circle. So this is the dynamical behavior in the limit of alpha plus beta equals 2. So the crucial point is that there is no fixed point. One is drawn towards a limit cycle for this special case.